Before the first light, there was silence, a silence deeper than any void we can imagine, not merely the absence of sound, but the absence of time itself. No ticking of clocks, no measure of before or after, only stillness, unbroken, unshaped, unborn. From this nothingness, the cosmos had yet to rise. There was no star to burn, no dust to scatter, no horizon to separate one thing from another. Even the word nothing strains to capture it. For what does it mean to speak of absence before the idea of presence was possible? And yet, from this quiet beyond quiet, a spark. The first fire, the first breath, the first unfolding. In less than a heartbeat, energy unfurled into matter, and matter into form. From the unseeable, the vast web of galaxies would one day stretch. From the silent pause, time itself began to count. It is the paradox that haunts both science and philosophy. How can something emerge from nothing? Did the universe awaken from a void? Or has it always existed in forms beyond our reach? Every atom in every body, every flame of every star, carries within it the trace of that moment. And so the question lingers. Was there truly a beginning? Or do beginnings only exist in the minds that yearn to know them? This is the story that all of existence whispers back to us, an echo that refuses to fade, the echo of the first breath. If you are new here, join the journey. Like, subscribe, and let's begin. Before the equations of Einstein, before the telescopes of Hubble, before the whispers of microwave light that revealed the young universe, there were only eyes lifted to the stars. For tens of thousands of years, humanity gazed upward at the glittering expanse of night, searching not only for guidance, but for origin. The sky became both map and mirror. Its endless depth seemed to ask a question that pressed upon every tribe, every empire, every solitary dreamer. Where did this vastness begin? And where, within it, do we belong? Across the earth, ancient cultures gave voice to this mystery, not with equations, but with stories, not with instruments, but with symbols carved into myth. In the river valleys of Mesopotamia, scribes etched the Enuma Elish, a creation epic in which chaos waters churned until the gods split them apart, fashioning heaven and earth from the body of a slain dragon. Here, the universe was born in violence, shaped by cosmic struggle, ordered from the blood of chaos in the temples of Egypt. Priests recited the tale of Atum, the self-created one, who rose from the primeval waters of Nun. In their vision, existence emerged not from war, but from solitude, a god drawing breath into the silence. Speaking creation into form far to the east, in India, the Vedic hymns sang of a golden embryo, the Hiranyagarbha, the cosmic egg that floated in the void from its radiant shell. The universe unfolded, life blooming from a single, sacred seed. It is a vision hauntingly close to what modern science would one day call the singularity. An entire cosmos compressed into an origin beyond comprehension. The Greeks, gazing at the night sky where constellations traced the stories of gods, wrestled with a different language of creation. Philosophers like Anaximander and Parmenides began to speak of a pairon, the boundless. For them, the universe was eternal, without beginning or end, a stage upon which cycles repeated endlessly. And yet even here, the same paradox lingered. If everything is eternal, how does anything truly begin? Across oceans, the Maya told of successive worlds, born and destroyed in repeating cycles of creation and collapse. The Popol Vuh describes gods who fashioned humans first from mud, then from wood, and finally from maize. Each attempt a cosmic experiment, echoing failure and rebirth. Theirs was a universe of endless rehearsal, where beginnings were never final, but woven into spirals of renewal. And in China, philosophers spoke of the Tao, the eternal way, from which yin and yang diverged. Here, creation was not an explosion, but a balance, a breathing of opposites into harmony. The cosmos not launched from a single event, but eternally unfolding, as natural as water flowing downhill. Though separated by vast distances and centuries, these myths reveal a shared truth. Human beings could not live without a story of beginnings. Each vision mirrored the land, the struggles, the fears of its people. But beneath their differences, a thread connects them all, the conviction that existence is not accidental, that the universe carries intention, order or rhythm, even if veiled in mystery. And yet, within these stories lies something more, a whisper that resonates with the scientific pursuit that would awaken, millennia later, the sense that the universe was once different. From what it is now, that time and space themselves were not fixed, but born from transformation. Modern cosmology would one day replace gods with equations, myths with data. But the question remained the same. The ancients, staring at the fire of stars, asked with reverence physicists, staring at the glow of the cosmic background. Ask with mathematics, both stand before the same unfathomable abyss. How does everything begin? It is not coincidence that modern scientists borrow the language of myth when speaking of origin. They speak of the cosmic egg, of primordial fire, of the birth of time itself. The vocabulary of physics, even in its precision, cannot escape poetry. For the beginning of the universe is not merely a scientific problem, it is a human wound, a longing, a hunger older than history. What is astonishing is not that ancient civilizations imagined so many beginnings. It is that they felt compelled to imagine them at all, for in their gaze at the heavens was a recognition that everything seen must have once been unseen. That stars, however eternal they appear, must themselves have risen from darkness, that we, fragile and temporary, are threads in a story that began before us. In this, the ancients and the scientists share a kinship. For to ask of beginnings is to ask of meaning. And whether through divine spark or quantum fluctuation, through cosmic egg or inflationary field, the mystery is the same. Something emerges where nothing stood before, and from that emergence comes everything, every galaxy, every atom, every life, every dream. The ancients whispered of beginnings through story. We now whisper of them through science, but the awe remains unchanged. The universe, silent and infinite, still looks back at us with the same unanswerable question. And so begins the journey, from the myths of the first storytellers to the instruments that now reach into the silence before stars. The question of beginnings, once painted on cave walls and temple stones, now written in light and mathematics, yet still, in both science and story, the same haunting refrain endures. What was there before the beginning? At the dawn of the 20th century, the universe was thought to be eternal and unchanging, a vast and silent cathedral of stars, suspended forever in perfect stillness. This vision was comforting, a cosmos with no beginning, no end, a stage that simply was, but the sky would not keep its secrets forever. The truth was already hidden in the faint whispers of light crossing the void, waiting for human eyes and instruments sharp enough to hear through the thin mountain air of California. At the newly built Mount Wilson Observatory, a giant telescope opened its gaze upon the heavens. Here, Edwin Hubble studied the faint smudges of light once thought to be clouds within the Milky Way patiently. He measured the brightness of stars within them, comparing the rhythms of Cepheid variables, stars whose pulses revealed their true distance. What he uncovered was astonishing. These smudges were not part of our galaxy at all. They were entire galaxies in their own right, island universes adrift in a sea far larger than anyone had dared imagine. The cosmos, once thought small, now stretched outward without end, but the light carried another secret. When Hubble measured the spectra of these galaxies, he noticed something unsettling. The familiar chemical fingerprints were shifted, stretched toward the red end of the spectrum. This was no error, no quirk of measurement. The galaxies were racing away from us. Everywhere he looked, the heavens were retreating. The implication was profound and deeply unsettling. If galaxies were moving apart, then the universe was not static at all. It was expanding. And if it was expanding now, then long ago it must have been smaller, condensed, hotter, closer to something that might be called a beginning. This was not what science expected. Even Albert Einstein, whose equations of general relativity already hinted at a dynamic universe, had resisted the idea. His mathematics suggested that space itself should be stretching or collapsing. But the thought was too radical, too destabilizing. He added a cosmological constant to force the cosmos back into stillness. A patch, a correction, a way to preserve the eternal universe he believed in. Later, he would call it his greatest blunder, for the discovery that space itself was expanding struck at the deepest roots of human imagination. The eternal cosmos was gone. The universe had a history, and what has a history must also have a birth. It was a philosophical earthquake for centuries. Scientists and philosophers alike had imagined existence as timeless now. Suddenly, time itself seemed to have a direction, a flow that reached back toward an origin. Every star, every planet, every atom must once have been gathered together in a single, unimaginable state. The light of galaxies had revealed not only their distance, but the story of the universe itself, written in faint red shifts across the sky, was a truth almost too vast to accept. That the universe was not a monument of permanence, but a living, changing thing, and with this realization, an older question rose again, one whispered in myths and carved in stone by ancient civilizations. If the universe expands outward now, from what did it expand? What moment, what event, what mystery lies at the heart of that first unfurling? Science could not yet answer, but the balance had shifted, the stars had spoken, and their message was clear. The universe is not eternal. It is a story, and it has a beginning. The discovery was not met with celebration alone. Many resisted, clinging to the steady-state view, unwilling to accept the disruptive idea of cosmic birth. Some argued that the data could be explained otherwise, that new matter was continuously appearing, keeping the universe eternal even as it expanded, but the evidence would only grow stronger with time. The light itself could not be silenced philosophically. The idea was staggering, for if everything has expanded from an earlier state, then all that exists, galaxies, stars, the earth beneath our feet, shares a common origin. The boundaries between here and there, now and then, blur. The universe becomes a single unfolding event, and in that realization is a deeper unease. If the universe is expanding, will it expand forever, or will gravity one day call it back, collapsing everything into an end mirroring its beginning? The question of origins is tied to the question of destiny. The first breath of the universe carries within it the final one. What Edwin Hubble saw through the great eye of Mount Wilson was more than a measurement of galaxies. It was a vision of time itself, a revelation that the universe is not static, but alive with motion, with history, with possibility. The light that traveled millions of years to reach his telescope carried the memory of expansion, each photon a witness to a universe in flight. This was the first clue written in light, the first scientific evidence that the cosmos we inhabit is not eternal, but born of something deeper, more mysterious, a revelation that prepared the ground for the theory that would follow the idea of a Big Bang. A beginning written not in myth, but in mathematics and observation. Yet even here, in the triumph of discovery, uncertainty remained. For to know the universe is expanding is not the same as knowing how it began. The galaxies flee into the dark, their light stretched thin across the void, but they do not tell us what lit the first spark. That question would haunt science for the decades to come. And with it, the human spirit would be carried deeper into the mystery of beginnings. In the years after Edwin Hubble revealed that the universe was expanding, a profound unease spread across the world of science. The stars were no longer eternal ornaments of the sky. They were participants in a story that seemed to demand a beginning, and beginnings are unsettling things. Among those who looked deeper into the mystery was a Belgian priest and physicist named Georges Lemaitre, working in the 1920s. Lemaitre examined Einstein's general relativity and Hubble's evidence of expansion. Where others saw contradiction, he saw possibility. If the universe is expanding now, he reasoned, then in the distant past, it must have been compressed into something unimaginably small. He called this the primeval atom, a single, dense point that contained all the matter and energy of the cosmos. From this atom, he suggested, the universe had burst forth in a kind of primordial fireworks, giving rise to space, time, and all the galaxies that would one day fill the night sky. It was a daring vision, radical in its simplicity, a universe with a beginning, a universe born in fire. But science is not quick to embrace revolutions. Many scientists resisted the idea, unsettled by its echoes of religious creation stories. Einstein himself dismissed it at first, telling Lemaitre, "Your calculations are correct, but your physics is abominable." Others preferred the comfort of a steady-state universe, a cosmos that expanded. Yes, but one in which new matter continuously formed to fill the gaps, keeping everything eternal and unchanging to them. The steady-state theory preserved both mathematical elegance and philosophical stability. A universe without a beginning meant a universe without the troubling question of what came before. For decades, the two visions existed side by side, the Big Bang and the steady state, the fiery birth and the eternal cycle. Each with supporters, each with doubts the cosmos itself would have to decide between them. That decision came not from theory, but from an accident. In 1964, two radio astronomers, Arno Penzias and Robert Wilson, were working with a large horn-shaped antenna at Bell Labs in New Jersey. They were not searching for the origins of the universe. They were trying to eliminate background noise that interfered with their communications research. But no matter what they did, the noise remained a faint, persistent hiss, spread evenly across the sky, day and night. They cleaned the antenna, even removing nesting pigeons and their droppings. Yet the signal would not go away. What they had stumbled upon was not interference, but a message. The afterglow of creation itself, the cosmic microwave background, faint radiation left behind from the universe's earliest moments, when the cosmos was young and filled with a hot, dense plasma of particles and light. As the universe expanded and cooled, that light stretched, redshifted, until it reached the microwave spectrum. It had been traveling ever since, a silent echo of the first fire. When Penzias and Wilson's discovery became known, it was immediately recognized as the missing evidence. The steady-state theory could not explain this glow, but the Big Bang could. For if the universe began in a hot, dense state, then there should be a relic of that primordial heat, now cooled to just a few degrees above absolute zero. The microwave background was that relic, still bathing the cosmos in its faint and uniform whisper in one moment. The debate ended. The Big Bang had moved from speculation to observation. The universe itself had spoken through its ancient light. It is difficult to grasp the magnitude of what was revealed. The cosmic microwave background is not simply a piece of evidence, it is a time machine, a photograph of the universe when it was only 380,000 years old, when the first atoms were forming and light was finally free to travel. In its patterns lie the seeds of everything, the slight variations in density that would one day grow into galaxies, stars, and the planets that cradle life. To look at the cosmic microwave background is to gaze at the infant face of the cosmos. And in that face, humanity saw confirmation that the universe was born not in eternal stillness, but in fire and expansion. The discovery was awarded the Nobel Prize in Physics, but its true prize was philosophical. For with the Big Bang established, the universe now had a beginning in time, and with beginnings come questions of origin that science still struggles to answer. If everything emerged from a primeval atom, what set it into motion? If time itself began with the Big Bang, what does it mean to ask what came before? The cosmos had given up one of its deepest secrets, only to expose even greater mysteries. The Big Bang explained how the universe grew from its earliest fire, but it did not explain why that fire existed at all. Still, in that faint background glow lies the greatest story ever told, a story written not in myth, but in radiation. Every microwave photon that falls upon a detector carries the memory of the universe's first moments. The cosmos itself remembers. And through the persistence of light, humanity now remembers too. The birth of the Big Bang theory was more than the triumph of one idea over another. It was a shift in human imagination, from the eternal to the finite, from the static to the dynamic, from the comfort of unchanging heavens to the mystery of a universe alive, evolving, with a beginning carved into its very fabric. And with this revelation, the journey only deepened, for to know the universe was born is to ask, born into what? The Big Bang answers how the cosmos expanded, but leaves unspoken the silence from which it arose. That silence still lingers, vast and unbroken, at the edge of knowledge and into it. Science continues to reach, listening for whispers older than time. In the archives of human thought, there is no question more unsettling, no mystery more absolute, than the moment when nothing became everything. The universe, vast beyond measure, once lay compressed into a state so dense, so unfathomably small that words strain and equations fracture beneath its weight. Cosmologists call it a singularity, not because it is understood, but because it marks the edge of understanding itself. Here, matter had no atoms, no particles, no stars. Energy had no waves, no light, no radiation. Space did not extend because there was no extension to measure. Time did not tick because there was no before to compare against an after. The singularity was not a thing within the universe. It was the seed from which the universe itself would erupt. For ordinary intuition, this picture feels impossible. The human mind is sculpted by landscapes and rivers, by the rhythm of night and day, by the solidity of ground beneath the feet. How can such a mind grasp an epoch where ground, sky, and even the march of moments did not exist? Physics itself recoils here. Relativity, which describes the curvature of space and time with elegance and precision, collapses into infinities at the singularity. Quantum mechanics, which governs the smallest of particles, refuses to be stretched over so vast and total a beginning. The laws that hold up the universe buckle when asked to explain its birth. And yet, despite this paradox, science has traced the unfolding of events that followed, almost instantly after the singularity's veil. In the first fraction of a second, less than 1/trillionth of a second, inflation is thought to have begun, a swelling of space itself, expanding faster than light, smoothing and stretching the newborn cosmos. From a quantum tremor, a fluctuation smaller than an atom, grew the scaffolding of galaxies and clusters, filaments and voids. It was in this unimaginable instant that randomness became structure, and chaos became the first whisper of order. But the beginning itself, the moment of nothing becoming everything, remains untouchable. Did it occur within time, or did time begin with it? If time had a birth, then the very notion of before dissolves into silence. The question itself might be meaningless, a relic of human language reaching beyond its capacity. And yet, it is precisely this meaningless question that haunts the imagination. In every era, humans have asked, what came before the beginning? Ancient myths spoke of gods and fires, of oceans and chaos. But modern physics, stripped of metaphor, confronts the same unease. Some suggest that the universe was born not from nothing, but from a quantum foam, a restless sea of fluctuations where particles flicker in and out of existence, even in emptiness. Others imagine a multiverse, countless universes budding like bubbles, with ours simply one among an infinite foam. Still others argue that the singularity is not a beginning at all, but a doorway, a threshold where the known laws collapse, hiding a deeper reality yet unseen. The disquiet lies in the realization that science cannot yet say. Cosmologists can write the equations for what occurred a millionth of a second after the Big Bang. They can trace the cosmic microwave background, glowing faintly across the sky as the afterimage of the fiery birth. They can measure the drift of galaxies, the expansion of space, the cooling of the cosmos from plasma to stars. But the first instant, the crossing from nothing into everything, remains cloaked in mystery, and perhaps it must. For in that moment, the universe was not yet governed by the rules it would later invent. Time itself was still coalescing. Space was still finding its measure. To ask what was before may be like asking what lies north of the North Pole, a question whose shape carries no answer. Yet this does not diminish the wonder. Instead, it deepens it. For if the universe did arise from an infinitesimal state, then all of existence, every galaxy, every sun, every ocean and breath, was once compressed into a point smaller than a grain of sand. All of history, all of matter, all of light, lay hidden in that silent potential. It is a thought that bends the soul, that within nothingness lay the seed of everything, that within silence the music of the cosmos was already waiting to be played. Still, the mystery gnaws. Did the universe demand a beginning? Could it be eternal, stretching beyond comprehension? The Big Bang only one chapter in an endless cycle of expansion and collapse. Some models suggest a big bounce, a universe reborn from the ashes of a previous cosmos, as contraction turns to eruption. Others speak of eternal inflation, with universes endlessly budding from universes, each with its own physics, its own fate, and yet, even these grand visions are haunted by the same question. Why is there something rather than nothing? If the multiverse exists, why does it exist? If laws of physics allow for universes, who or what dictated those laws? The silence here is not one of ignorance alone, but of philosophy itself. Science maps the terrain of the possible, but the origin of possibility, the ground of being itself, remains hidden. And so, the story of the Big Bang is both triumph and riddle. Triumph, because humans have peered back nearly to the dawn, unraveling the history of stars and matter from the faint glow of ancient light. Riddle, because at the threshold of nothingness, knowledge halts and imagination alone steps forward. It is in this twilight between science and silence that wonder lives. For the greatest shock is not that the universe is vast, but that it exists at all, that from nothing, or from something beyond comprehension, there came everything. The galaxies now wheeling across the sky, the atoms that weave flesh and stone, the photons that burn in the eyes, all of them carry the signature of that unfathomable birth. To walk through the world is to walk through the echo of creation. To breathe is to breathe the cooled fire of the beginning. The singularity remains unseen, perhaps forever beyond reach, but its consequence is everywhere. It is in the weight of the earth, the pull of gravity, the shimmer of starlight, the unfolding of time. Every moment that passes is another ripple spreading from that first instant. And so the mystery endures. Nothing became everything. Silence became sound. Darkness became light. Time began to flow. And the universe, vast and ancient, began its story. A story whose first page no one has yet read. The universe keeps its oldest memory in light. Not the light of stars, for stars had not yet burned. Not the light of galaxies, for galaxies had not yet formed. But a fainter glow, stretched thin by time, cooled by expansion, yet still washing across the cosmos like an echo of fire. This is the cosmic microwave background, the afterglow of the Big Bang, a ghostly radiation that fills all of space, whispering in microwaves, faint but everywhere. It is the oldest light humanity can see, released when the universe was just 380,000 years old, an infant still hot, yet cooling enough for atoms to form and photons to travel free. To read this light is to perform a kind of archaeology, not with stone or bone but with radiation. It is to brush away the dust of time and uncover the fossil record of creation itself. In the late 20th century, the task of uncovering this fossil was given to machines orbiting above Earth. The first was COBE, the Cosmic Background Explorer, launched in 1989. Its mission was simple in word, but vast in meaning to take the universe's temperature. What it revealed would transform cosmology. COBE's detectors confirmed with exquisite precision that the cosmic background was a nearly perfect blackbody spectrum, the thermal fingerprint of a universe born in fire and cooling with age. But within this smooth glow, COBE also glimpsed something more subtle, something hidden in the faint ripples of temperature across the sky. Fluctuations so slight they measured only 1 part in 100,000. Yet those tiny differences were not noise. They were the seeds of structure, the first wrinkles from which galaxies, stars, and planets would one day form. Stephen Hawking called COBE's discovery the most important scientific discovery of the century, if not of all time. For those ripples were nothing less than the imprints of the universe's infancy, frozen into light. A decade later, another satellite sharpened the picture. WMAP, the Wilkinson Microwave Anisotropy Probe, launched in 2001. Where COBE had seen a child's sketch, WMAP revealed a detailed portrait. Over 9 years, it traced the cosmic background with breathtaking precision, mapping the faint mottling of temperature across the heavens. Each blotch of warmth and coolness corresponded to regions where matter once gathered or drifted apart, under the pull of gravity and the push of radiation. From these subtle patterns emerged the most precise measurements of the cosmos ever made. WMAP determined the age of the universe to be 13.7 billion years, with an uncertainty of less than 1%. It measured the density of matter and dark matter, the balance of atoms and radiation, even the geometry of space itself. For the first time, cosmology became precision science. The Big Bang was no longer a hypothesis painted in broad strokes. It was a history, charted and measured with the rigor of astronomy and physics. Yet, within the elegance of the data, anomalies whispered. Among the cosmic ripples, scientists found oddities that defied the symmetry of expectation. The so-called axis of evil, a strange alignment of temperature fluctuations stretching across the sky, a cold spot larger and emptier than theory predicted, subtle asymmetries that seemed to hint at forces or conditions beyond the known laws. Were these anomalies mere accidents, the statistical flukes of cosmic chance, or were they fingerprints of deeper truths, the scars of collisions with other universes, or the echoes of physics older than the Big Bang itself? The data does not yet say, The whispers remain unresolved. In 2009, the Planck satellite carried the work even further, tracing the background with resolution finer than any before. It confirmed much of what WMAP had shown, solidifying the parameters of the cosmos with extraordinary certainty. But even Planck could not silence the whispers. The cold spot remained. The asymmetries persisted. The anomalies endured, as though the universe itself wished to keep its first chapter written in riddles. To gaze at the cosmic microwave background is to look at the oldest photograph ever taken, a picture not of stars but of the universe itself in childhood. The ripples that COBE and WMAP revealed are the very fingerprints of creation, etched into radiation. From them, scientists have read not only the story of galaxies, but the values of cosmic constants, the very numbers that dictate the fate of existence. And yet those same ripples carry mysteries unsolved. Like artifacts half buried in sand, they hint at deeper origins. Did inflation, that sudden swelling in the universe's first instant, leave behind these marks as its calling card? Did quantum fluctuations, magnified to cosmic scales, sculpt the texture of the sky? Or do the anomalies point to something stranger still? Dimensions unseen, universes adjacent, a prehistory before the beginning. Cosmic archaeology is not finished. Each measurement digs deeper into the light, peeling away layers of time. Each anomaly beckons toward questions larger than answers. The map grows sharper, but the silence at its edges grows louder. For now, the cosmic microwave background remains both revelation and riddle, a relic of fire that tells the tale of how everything came to be, a canvas of ripples that charts the birth of structure, and within its noise, the faintest suggestion that there is still more to the story, that the universe, even in its infancy, was already keeping secrets. And so, the archaeologists of light continue their work. Their tools are satellites, their brushes are detectors, their ruins are the patterns of ancient radiation. Each pixel mapped is another fragment of the past recovered. Each anomaly uncovered is another question posed. The first light has been read, but it has not been fully understood. The cosmic background is the universe's oldest whisper, and somewhere within that whisper may lie the faintest echo of what came before. The story of the beginning does not end with fire, for behind the curtain of the Big Bang, in a time so brief it strains the imagination, the universe may have undergone a transformation so extreme, so violent and so sudden that all of known existence was reshaped in an instant. This is the idea of cosmic inflation, the great stretch that may have sculpted the universe into the form we see today. It begins less than a trillionth of a second after the supposed birth of time, a moment when the universe was smaller than a proton, yet filled with unimaginable energy. In this fleeting interval, space itself may have expanded faster than the speed of light, swelling outward by a factor greater than numbers can easily convey. Distances that were once subatomic were pulled apart to scales larger than galaxies. The entire observable universe was inflated from a seed too small to see, a transformation so total that it rewrote the conditions of existence. The architect of this idea was a young physicist named Alan Guth. In the late 1970s, Guth was studying problems with particle physics and cosmology, searching for explanations of the early universe's behavior. In 1980, he proposed a radical solution. What if, in its earliest fraction of a second, the universe had been driven by a peculiar kind of energy locked in a false vacuum, a state of space itself filled with latent energy? Such a state would create a repulsive force, one strong enough to drive exponential expansion. A universe that had once been tiny could balloon outward in a heartbeat. The implications of Guth's idea were staggering. For decades, cosmologists had wrestled with puzzling questions about the universe. Why is the cosmos so flat? Its geometry stretched as though balanced on the edge of a knife. Why does the universe look so uniform in all directions, when distant regions should never have had time to communicate or exchange heat? Why is the cosmos filled with just enough matter and energy to hover between eternal collapse and endless expansion? Inflation offered answers. By stretching space at unimaginable speed, inflation smoothed out the wrinkles of the infant universe. It flattened its geometry. It allowed once tiny regions, once in close contact, to grow into the vast expanse we see today, carrying with them the same temperature and density. Inflation, in a single sweep, explained the flatness, the horizon problem, the uniformity, the strange coincidences that had long troubled cosmology. But inflation was more than a mathematical trick. It made predictions that could be tested. If inflation had occurred, then the tiny quantum fluctuations that ripple through the vacuum, the restless jitter of fields and particles, would have been stretched across the universe itself, magnified into vast structures. Those fluctuations would become the seeds of galaxies, the faint ripples frozen into the cosmic microwave background. And indeed, when satellites like COBE, WMAP, and later Planck scanned the heavens, they saw precisely that, a sky dappled with temperature variations that matched inflation's predictions almost perfectly. The fingerprints of inflation were etched into the oldest light. What began as subatomic quantum whispers had grown into the great architecture of galaxies and clusters that now shape the cosmos. Yet with each answer, inflation opened new questions. What triggered it? What force or field could create such a runaway expansion? And equally mysterious, what ended it? For inflation, if left unchecked, would continue without bound. Space would stretch forever, tearing reality into disconnected domains. This possibility gave rise to an even stranger consequence: eternal inflation. In this vision, inflation never truly ends everywhere at once. Instead, it ceases only in isolated pockets, while in other regions it continues unchecked. Each pocket where inflation halts becomes a universe, cooling, condensing, and giving rise to stars and galaxies. Beyond it, inflation rages on, spawning still more universes in an endless cosmic sea. This is the multiverse, the grand speculation that our universe is not unique, but one bubble among countless others. Each bubble may follow different laws, shaped by different quantum fields, different strengths of gravity, different balances of matter, a vast and eternal foam of realities, most forever beyond one another's reach. To some, this idea borders on metaphysics, an escape into speculation where observation cannot follow. To others, it is the natural extension of physics, the unavoidable consequence of inflation's mathematics. If inflation is true, the multiverse may be not fantasy, but inevitability. But even this vision does not silence the unease, for inflation itself demands an origin. If space could inflate, what set it in motion? If it ended in our universe, why did it begin in the first place? Was there a field, a particle, a deeper law that sparked the sudden rush of expansion? Or was inflation itself an echo of something older? A prehistory before the Big Bang, a mechanism woven into the fabric of reality beyond time. Physicists have sought to probe inflation's truth through subtle signs. The most tantalizing would be primordial gravitational waves, ripples in space-time generated by the fury of inflation's expansion. These waves, frozen into the polarization of the cosmic microwave background, would be the smoking gun of inflation's reality. In 2014, an experiment at the South Pole announced such a detection, only to later discover the signal was contaminated by galactic dust. The search continues, as telescopes on Earth and in orbit strain to catch whispers of those first gravitational tremors. Inflation remains a theory, but one of extraordinary power. It takes the chaos of beginnings and renders it comprehensible, transforming mystery into prediction, disorder into structure. Yet in its heart lies paradox. An idea that explains so much, while demanding answers still out of reach. The great cosmic stretch gave the universe its shape, its flatness, its uniform glow. It seeded the galaxies, the stars, the possibility of life. And perhaps, in the boundless continuance of inflation, it spawned worlds without number, each with its own story of beginnings. But if this is so, then the question grows heavier. For even if inflation birthed our universe, it cannot be the first cause. Something lit its fuse. Something stirred the field, bent the vacuum, and made the cosmos erupt into expansion. Inflation answers the riddle of structure, but not the riddle of existence. It gives the how, but not the why. The universe is stretched, smoothed, sculpted by this great expansion. Yet still it asks, what was there before the stretch? What law? What field? What hand, natural or otherwise, opened the gate from nothing into everything? Inflation solved mysteries once thought insurmountable, but it left behind mysteries even greater, and in that balance of answers found and questions deepened lies the beauty of the search. The universe is not only vast in distance, but vast in meaning. Each discovery carries us forward, yet each discovery reminds us that beginnings still lie in shadow. The cosmos stretches before us, as it once stretched into being. and the silence of its first instant remains, waiting, just beyond the edge of knowledge. The closer one approaches the beginning, the stranger the universe becomes. At cosmic scales, gravity curves space, galaxies dance in great structures, and expansion stretches the heavens. But at the smallest scales, at the frontier of the very beginning, reality trembles with a different set of rules. Here, the strange theatre of quantum mechanics reigns, and in its stagecraft, the universe itself may have been born. Quantum physics tells us that the vacuum of space is never truly empty. Even in perfect darkness, fields fluctuate, particles and antiparticles spark into being, then vanish in less than an instant. This restless jitter, known as quantum fluctuations, is not an imperfection, but a law of existence itself. The uncertainty principle, Werner Heisenberg's profound insight, dictates that energy and time, position and momentum can never be precisely fixed. At the heart of reality lies indeterminacy, a ceaseless churning of possibility. It is within this vacuum uncertainty that cosmologists find a possible origin of everything. For if the vacuum seethes with fluctuations even now, then in the extreme conditions of the primordial universe, such fluctuations could have been magnified to cosmic scale. Tiny variations of density, stretched by inflation, became the imprints we now see in the cosmic microwave background. From those quantum ripples, matter clumped, stars ignited, galaxies assembled. Every atom of every being may trace its ancestry to those uncertain tremors in the fabric of nothingness. To contemplate this is to step into a paradox. For if fluctuations are inherent to the vacuum, then perhaps the universe needed no external cause. Perhaps existence itself is the natural flowering of quantum law. In such a view, nothingness is unstable, not void, but potential. Given time, or given no time at all, it erupts into being. Yet this raises questions as deep as it resolves. For what then is the vacuum? What are the quantum fields whose fluctuations sowed reality? Physics today describes them in terms of mathematics, the language of quantum field theory. But the substance of these fields, whether they are mere descriptions or true realities humming beneath space and time, remains uncertain. Still, the evidence of their imprint is written in the heavens. The ripples seen by Kobe, WMAP and Planck are not random. They follow the statistical patterns expected from quantum origins. The universe itself appears to be a magnified quantum event, stretched across billions of light years. In every cluster of galaxies lies the echo of uncertainty. In every star is the memory of quantum fluctuation. This vision unsettles as much as it inspires. For if the universe emerged from quantum law, then causality itself bends under the weight of the beginning. We are accustomed to stories of origins with triggers and causes, an egg cracked by a hand, a spark struck by flint, a wave begun by wind. But in quantum physics, events may occur without defined cause, only with probability. The universe, then, may not have been pushed into being by anything outside itself. It may have simply been possible, and in being possible, it became real. Some physicists describe this as a quantum creation event, a tunneling of existence out of a vacuum state. In one mathematical picture, the universe is born not from absolute nothing, but from a quantum foam where fluctuations allow space-time to blossom spontaneously. In another, the universe emerges as a kind of wave function, a probability that resolves into actuality. Yet these are not final answers, but glimpses. For the mathematics of quantum cosmology remains incomplete. The fusion of quantum mechanics with gravity, the great unfinished project of physics, still eludes us. Without that union, the deepest beginning cannot be fully described. String theory, loop quantum gravity, and other frameworks attempt to provide the foundation, but none yet hold the consensus of truth. Still, the implications of quantum origins ripple outward into philosophy. If the universe arose from quantum fluctuation, then it is not an exception to natural law, but the ultimate expression of it. The cosmos is not imposed upon nothingness. It is what nothingness does when governed by quantum rules. Existence becomes the ground state, the inevitable unfolding of probability. But another possibility whispers, more haunting still. If fluctuations can give rise to one universe, could they not give rise to many? Just as inflation suggests a multiverse of bubbles, quantum theory suggests a frothing foam of emergent realities. Some might appear and vanish in the blink of cosmic time. Others might swell and endure, each with its own constants, its own galaxies, its own questions of origin. In this picture, Our universe is one outcome among infinite rolls of the quantum dice. And yet, even this grand vision does not escape mystery. For the laws of quantum mechanics themselves beg explanation. Why should uncertainty exist? Why should fluctuations ripple at all? Why should probability, rather than certainty, rule the deepest foundations? If quantum fluctuation is the spark of everything, then what is the source of quantum law itself? Here physics meets philosophy at the edge of language. Some argue that asking what came before may be meaningless, that time itself is a child of the universe, and to seek a cause before time is to seek a shadow before the sun. Others suggest that deeper theories, not yet written, will reveal why quantum law exists and why reality is restless rather than still. In the silence of that uncertainty lies a profound thought. The universe may have no cause beyond its own possibility. It may exist not because it was willed, nor because it was inevitable, but because probability itself could not remain unexpressed. To be was among the chances of nothingness, and once it was possible, it was real. Thus, the galaxies overhead, the stars within them, the atoms within us, all may be traced to a fluctuation, a whisper in the quantum vacuum, a tremor without cause, magnified by inflation, stretched by expansion, sculpted by gravity, and burning now as suns and life. The origin of the universe is written not only in light, but in uncertainty. The first seeds of being were not certainties, but probabilities. And from probabilities, everything came. Quantum origins do not erase wonder, they deepen it, for they reveal that the universe is not an exception to order, but the most profound expression of it. An existence woven from the very uncertainty that lies at the heart of reality. And perhaps, within that uncertainty, the greatest mystery remains. Not that the universe had a cause, but that it may not have needed one at all. At the heart of cosmology lies a riddle too dense for equations to contain. A riddle known as the singularity. Singularity is not simply a place, nor merely a moment in time. It is the point at which the known dissolves into the unknowable. A place where gravity becomes infinite, where matter is crushed into nothing, and where the familiar mathematics of physics surrender their authority. General relativity, Einstein's great masterpiece, describes the bending of space and the flow of time with exquisite precision. It explains the orbits of planets, the collapse of stars, the dance of galaxies across billions of light years. And yet, when the equations are traced back to the very beginning, when the expanding universe is rewound to its first instant, they point towards something they cannot themselves describe. An origin that is less a beginning than a rupture in understanding. This rupture was made explicit by the work of two figures who reshaped 20th century thought, Roger Penrose and Stephen Hawking. In the 1960s and 70s, they developed mathematical theorems that revealed an unsettling truth. If general relativity is correct, then space-time itself must have a beginning. Singularities, they argued, are not mathematical quirks that can be ignored or patched over. They are inevitable features of Einstein's framework. Black holes end in singularities, and the universe itself, when followed backward, must have arisen from one. It was a revelation both thrilling and disquieting physics, which had always been a lantern in the dark, here admitted that its light could extend only so far beyond the singularity. Beyond that first point lay something the equations could not penetrate. No coordinates, no clocks, no reference frame, only a silence beyond reason. This silence raises a question that no experiment can easily approach. If time itself emerged with the universe, what could it mean to speak of a before? What stands on the far side of the first moment if the very concept of moment has not yet been born? The singularity at the Big Bang is unlike any frontier humanity has faced. When explorers reached the ends of maps, they found new continents. When microscopes and telescopes stretched vision, they uncovered new scales of existence. But here, in the depths of the cosmic beginning, the very rules by which exploration is possible dissolve. It is not simply that answers are missing. It is that the questions themselves may not fit the reality that existed before physics itself, and yet, physics does not abandon the attempt quantum mechanics, whispers of fluctuations and uncertainty. Inflationary, theory sketches an expansion that softens, the violence of the singularity string theory, suggests that perhaps the point of infinite density is replaced by vibrating dimensions, curled in hidden geometries. Loop quantum gravity proposes that space-time itself might be woven from quanta, preventing infinite collapse. Each approach offers a bridge, fragile but hopeful, across the abyss where Einstein's equations fail still. None erase the haunting paradox. If the laws of physics are born with the universe, then they cannot explain their own birth. If the stage of reality did not exist before the first act, how can science speak of causes? Here lies the escalation of mystery, not only the unknown, but the unknowable. This realization carries a philosophical weight as heavy as any scientific conclusion. It forces reflection on the nature of explanation itself. Every child of reason asks, why? Why the stars shine? Why galaxies turn? Why time flows? But at the singularity, the word why dissolves, not because answers are hidden, but because the grammar of existence has not yet been written. The singularity also sharpens the tension between relativity and quantum mechanics. General relativity bends smoothly across vast scales, while quantum theory shivers with probability in the subatomic realm. At most places in the universe, the two domains coexist without conflict, but at the singularity, where matter is crushed into impossibility, both are demanded at once, both break under the strain. It is here that the search for a theory of everything finds its urgency, not to satisfy curiosity alone, but to reconcile the torn fabric of understanding. Stephen Hawking himself once described this tension with striking clarity. If the universe has a beginning at a singularity, then it seems to require a cause outside the laws of physics. Yet if physics is to be complete, it must describe its own birth without appeal to something beyond caught between these demands. Science confronts a boundary as profound as any horizon in nature. Some thinkers suggest that perhaps singularities are illusions, artifacts of pushing current mathematics beyond their rightful domain. In quantum gravity, space and time may be discrete, built of finite grains that prevent infinities from ever forming in such visions. The singularity is replaced by a bounce, a passage through collapse into expansion. The universe, in this view, may not have begun but rebounded, one cycle among countless others. Others hold that singularities are real, and that they mark the edge of physics as a map marks the edge of the known world beyond them. No theory can extend, because the very concepts of space, time, and causality evaporate. Both views are haunting in one. The universe hides its prehistory in veils of quantum foam. In the other, the beginning is absolute, a boundary no intellect can ever cross. And so the singularity stands not only as a problem of equations, but as a mirror of human limitation. It reflects back the fragility of knowledge, the humility demanded of those who seek origins. To confront the singularity is to stand at the threshold of everything and admit that the door may not open. Yet perhaps this is not defeat, but invitation, for the singularity is also the wellspring of imagination. It inspires theories that stretch mathematics into new realms. It calls physicists to weave relativity and quantum mechanics into one tapestry. It reminds philosophers that mystery is not an enemy of knowledge, but its companion. The escalation of mystery, then, is not the collapse of understanding, but its renewal. It is the recognition that at the root of the universe lies not a simple answer, but a paradox that deepens with every attempt to resolve it. And so, as science peers into the abyss of the singularity, it finds not only the limits of equations, but the pulse of wonder itself. For in the recognition that physics may have been born with the cosmos, one glimpses the most profound truth of all, that the universe is not merely something to be understood, but the very source of understanding itself. Here, at the boundary of knowledge, science does not end, it begins again, sharpened by paradox, humbled by infinity, and illuminated by the silence from which everything arose. The human mind cannot rest at an ending. When it confronts a boundary, it imagines what lies beyond, and so, at the precipice of the cosmic beginning, science has offered visions, each bold, each incomplete, each a mirror of humanity's refusal to accept finality. The most ancient of these visions is the dream of cycles, the idea that the universe does not begin and end once, but breathes eternally in rhythms of collapse and rebirth. In this picture, the Big Bang was not the first, nor will it be the last. A universe expands, thins, and cools until gravity recalls it home, drawing galaxies together in a fiery implosion known as the Big Crunch. From that collapse, a new explosion ignites, birthing another cosmos, another sequence of stars and lives. Modern cosmology has revisited this idea in cyclic models, universes rebounding like a heartbeat across timeless ages. The mathematics of loop quantum cosmology suggests that quantum gravity may prevent a true singularity, replacing it with a bounce. If true, then the beginning was not an origin, but a transition, a note in an eternal symphony. Yet cycles face their own dilemmas. Observations show that the cosmos is not slowing toward collapse, but accelerating outward, driven by the unseen force called dark energy. If expansion never reverses, the eternal rhythm may be silenced, leaving the cyclic vision as a dream rather than a destiny. Another possibility arises from the strange laws of the quantum world. In quantum mechanics, particles can tunnel through barriers they should not cross, emerging into existence where none was possible. Applied on the grandest scale, some theorists propose that the universe itself may have tunneled into being from a state of pure quantum vacuum. A vacuum not of emptiness, but of potential, where uncertainty allows reality to flicker into form. Physicist Alexander Vilenkin has described this as a creation from nothing, not a material nothing, but a nothing defined only by the laws of quantum physics. In this telling, the cosmos did not require a cause outside itself, it simply blossomed as a fluctuation, a self-contained birth within the restless fabric of possibility. And yet this picture raises an unsettling paradox. If the universe arose from the laws of quantum mechanics, then those laws must already have existed before space and time. But can laws exist without a world to apply them? Are they eternal truths or merely descriptions of the universe we inhabit? The vision of quantum tunneling solves one mystery, only to deepen another. String theory offers another horizon of speculation. In its mathematics, particles are not points but vibrating strings, resonating at different frequencies to become the matter and forces of nature. This framework requires extra dimensions, hidden beyond perception, and within this higher dimensional space, entire universes can exist as three-dimensional membranes, brains, floating in a vast, unseen bulk. Some cosmologists propose that the Big Bang may have been the result of two such brains colliding. In that cosmic impact, energy was released, igniting a new universe. The Bang, in this view, was not the beginning of all reality, but the birth of our local cosmos, one among many sheets drifting in the higher dimensional expanse. Such a picture transforms the singularity into an event, not an origin. It suggests that beyond our observable universe lies a wider stage, populated by worlds forever hidden, their presence revealed only in the mathematics of strings and brains. Yet even string cosmology leads into a deeper abyss, the idea of eternal inflation. Inflation, that rapid expansion in the first fraction of a second, may not be a singular event, but an endless process. Regions of space inflate, spawn universes, then continue expanding beyond them. Our cosmos would then be only one bubble in an infinite foam, each bubble a universe with its own laws, its own stars, perhaps its own lives. This multiverse vision is both exhilarating and disquieting. It answers the question of why our universe is so finely tuned for life. Because in an infinity of worlds, some must permit existence. And yet it also dissolves uniqueness, suggesting that everything that can happen does happen endlessly across uncountable realms still. Eternal inflation carries its own paradox. If it never ends, then there is no true beginning. No first universe, no ultimate origin. Only an endless fractal of births beyond comprehension, cause and effect, dissolve into an infinite regress, where the question of why becomes unanswerable because it need never be asked. Each of these theories, cycles, quantum tunneling, brain collisions, eternal inflation, offers not only a scientific possibility, but a philosophical mirror. They reveal how deeply humanity resists the notion of a final boundary. The cyclic model offers comfort in renewal, promising that endings are never absolute. Quantum creation whispers that the universe needed no outside cause, that existence is its own justification. String cosmology paints a vision of hidden dimensions and unseen collisions. Placing our cosmos within a greater whole, the multiverse diffuses finality altogether, scattering beginnings across infinity, and yet none can be confirmed with certainty. The universe leaves traces of its infancy in the cosmic microwave background, in the distribution of galaxies, in the whispers of gravitational waves. But beyond a point, the evidence grows faint, the signals too subtle to distinguish between competing visions. What remains is a landscape of possibility, each theory incomplete, each striving to illuminate what lies beyond the reach of direct observation. This diversity of ideas is not weakness but strength. It reveals that science, even at its limits, is not static. It is an unfolding dialogue between mathematics, observation, and imagination. A dialogue that mirrors the human spirit, forever reaching beyond what is known, forever refusing to accept the silence of an unanswered question. And perhaps this is the deeper truth hidden within the theories of birth, that the cosmos itself may be less a problem to be solved than a horizon to be approached. Each vision, whether of cycles, quantum tunneling, brain collisions, or eternal inflation, is not merely an explanation, but a metaphor of longing, a reflection of the human desire to escape finality, to believe that beyond the singularity, beyond the boundaries of time, there is always more. For even if science never resolves which, if any of these theories is correct, the act of imagining them transforms the very meaning of the beginning. It reveals that the birth of the universe is not only a scientific mystery, but a philosophical mirror in which humanity sees its own refusal to end at nothing. And so, at the close of these competing visions, one truth remains, that the universe, whatever its origin, is not an accident to be dismissed, nor a riddle to be quickly solved. It is a vast unfolding, whose very mystery fuels the fire of inquiry. The beginning may forever elude certainty, but the search itself becomes its own answer, an eternal dialogue between the cosmos and the minds it has awakened. The question of beginnings has always pressed against the silence of the unknown, but unlike ancient stargazers, who could only dream of origins, modern humanity now builds instruments of staggering reach, machines and mirrors that stretch vision into the abyss of time. Each device becomes a kind of time machine, peeling back the layers of distance, chasing after whispers of a moment when the universe itself first awakened. The James Webb Space Telescope was designed as one such eye launched into the cold shadows beyond the moon's orbit. It unfolds golden mirrors like petals of a mechanical flower, angled to capture light that has traveled for over 13 billion years. Its mission is not simply to map galaxies, but to witness the first dawn, to glimpse structures that emerged only a few 100 million years after the Big Bang. By studying faint, red-shifted light, Webb seeks the embryonic galaxies, clumps of stars igniting in darkness, seeds of the cosmic web we now inhabit. Each photon that strikes its instruments is a relic, a survivor of an age when the universe was young, when hydrogen clouds collapsed under their own weight to forge the first light in cosmic history. But even Webb cannot see beyond the epoch of transparency, the moment nearly 380,000 years after the Big Bang, when photons first slipped free of matter to form the cosmic microwave background. Before that release, the universe was a fog, opaque to light, drowning every spark in a sea of plasma. To probe earlier still, science must rely on messengers more elusive than photons. Particle colliders on Earth attempt to recreate these vanished conditions. Within the tunnels of the Large Hadron Collider, protons are hurled to near-light speeds and smashed together in bursts of energy, fleeting echoes of the temperatures that once filled the newborn cosmos. In those collisions, quarks and gluons swarm into existence, briefly forming the primordial soup that dominated the first millionths of a second. By studying how particles emerge and decay, physicists trace the forces that govern the universe at its birth. They seek to answer whether matter and antimatter truly balanced, or whether some hidden asymmetry tipped the scales toward existence. Without such an imbalance, the cosmos might have annihilated itself in a flash, leaving behind only radiation, no stars, no galaxies, no life. The collider becomes more than an engineering marvel. It is a kind of archaeological dig, but one that does not sift ancient soil. Instead, it reconstructs the physics of creation itself. Beyond light and particles lies another set of cosmic messengers, nearly silent, nearly invisible. Neutrinos. These ghostly particles flood the universe, passing through planets and stars without pause, born in nuclear reactions. They also trace their lineage to the very first seconds after the Big Bang. A cosmic neutrino background pervades all of space, even older than the microwave background, carrying imprints from the universe less than 1 second old. Detecting these primordial neutrinos would be like hearing a whisper from before atoms formed, a voice from the edge of time itself. Experiments deep beneath mountains and in frozen Antarctic ice already capture the rare flashes of neutrinos interacting with matter. Though the ancient ones remain hidden, if they can one day be heard, they may carry the fingerprints of creation. But perhaps the most promising messengers of all are gravitational waves, ripples in space-time itself, predicted by Einstein and finally confirmed in 2015 when detectors heard the collision of black holes. These waves move unhindered through matter, unscattered, undimmed. Unlike light, they could carry direct signals from the very birth of the universe. The violent stretching of inflation, if it occurred, would have left faint gravitational echoes imprinted across the cosmos. To detect them would be to listen to the heartbeat of creation itself, a rhythm resonating from the first fraction of a second. New instruments, from LIGO and Virgo on Earth to the planned LISA observatory in space, are tuned to seek these echoes, straining to catch vibrations that began before stars, before galaxies, before light together. These tools form humanity's great cathedral of inquiry. Telescopes unfolding in the vacuum of space, colliders buried beneath the Earth, detectors frozen into the poles, lasers stretching across continents. Each is built to push against the boundary of silence, to chase signals older than memory, fainter than imagination. Each is an act of defiance against the darkness that once seemed impenetrable. And yet, even with such instruments, questions remain. The universe may hide its deepest origins forever behind a veil, not of distance but of principle. If time itself began, there may be no observation that can reveal what came before. The silence at the boundary may not be filled, but may instead become a horizon, a place where knowledge meets its own edge. Still, the pursuit endures. For every discovery reveals not only the universe, but the nature of the human spirit. To look back 13 billion years is to see not only galaxies in formation, but humanity's refusal to accept ignorance. To smash particles together is to confront not only forces of physics, but the desire to know why there is something rather than nothing. To listen for gravitational waves from the first breath of time is to admit that the cosmos may never yield all its secrets. Yet to listen anyway, instruments reach where myth once stretched, where ancient poets imagined eggs of creation and sparks of divine fire. Modern science raises mirrors of gold and detectors of ice. The questions remain the same, though the methods have changed. What began everything? Why does the universe exist at all? Can silence itself give birth to stars? The James Webb Space Telescope peers toward the edge of light. Particle colliders reconstruct the first fires. Neutrino observatories wait in darkness for a whisper older than photons. Gravitational wave detectors stretch their arms into silence. Straining for a vibration from the dawn. Together, they form an orchestra tuned to a music that may never be fully heard. And yet the act of listening matters. For even if the universe guards its final secret, the pursuit itself becomes a kind of answer. A reflection of a species unwilling to surrender to mystery, unwilling to live without questions. Humanity builds these tools not only to know the beginning, but to define itself as the creature that searches, even when certainty may never come at the edge of time. The universe remains silent, but into that silence, humanity sends its machines, its mirrors, its dreams, and in their echoes, faint and fragile, is heard not only the story of the cosmos, but the story of those who dared to ask how it began. The story of the universe has always been a story of questions. Questions carved into stone, whispered beneath the dome of cathedrals, etched into the chalk of lecture halls. Each answer, when found, has never been a final word. It has always been the opening of a deeper abyss. When Newton described the laws of motion, it seemed as though the machinery of the heavens had been laid bare. Yet hidden beneath those equations waited relativity, a geometry of space-time that redefined gravity itself. When Einstein offered that vision, it seemed as though the fabric of the cosmos had been fully revealed. Yet lurking beneath his curves and light cones was the quantum, a world of probabilities, particles and waves woven together in contradictions. Every triumph of knowledge is a doorway. Beyond it, the light fades again into mystery. And so science, despite its immense power, forever stands on trembling ground. A structure built on provisional truths, each one destined to be surpassed. The universe allows itself to be measured. Its galaxies yield redshifts, its particles leave faint tracks, its waves ripple across detectors. But even as these measurements accumulate, the question of why remains elusive. Science has mastered the what of galaxies, the what of atoms, the what of expansion, of decay, of formation and collapse. But the why hovers beyond the reach of instruments. Why this universe and not another? Why laws at all instead of lawlessness? Why something instead of nothing? The fragility of knowing lies here. That knowledge is vast, but its foundations dissolve the closer one peers. Physicists ask how the universe began. They build telescopes to reach back in time, colliders to recreate the first sparks of creation. But even in the asking, there is a hidden assumption that time is a river with a beginning, that there was a before, a single first moment, a primal flash. What if time is not linear? What if the notion of a beginning is as illusory as the notion of an edge to the Earth once was? General relativity shows time stretching, bending, warping. Quantum mechanics hints at fluctuations where cause and effect lose their order. Theories like loop quantum cosmology propose that what is seen as a beginning may instead be a bounce, a cycle where universes rise and fall like breaths. String theory whispers of higher dimensional membranes colliding, birthing cosmoses not from nothing, but from interaction. In these visions, the beginning dissolves into a question that may itself be meaningless. To ask how the universe began may be to misplace the question entirely, to demand a first note where there may only be an eternal chord. The humility of physics is revealed here, not in equations written with certainty, but in the pauses, in the silences where language falters. Physicists admit with quiet honesty that their maps are incomplete. They may describe how matter behaves within the rules, but where the rules themselves come from, why they exist, or whether they exist at all, that lies in shadow. This fragility is not failure, it is a recognition of scale. The human mind, evolved to track the flight of prey across savannas, now asks questions about the birth of time itself. It is no wonder that the answers strain against comprehension. Science is not a fortress, but a bridge, reaching across darkness with beams of light that may never fully touch the far side. The fragility of knowing is mirrored in the tools themselves. Equations collapse into infinities when pushed too far. The Big Bang singularity, a place where density, temperature, and curvature all become infinite, is not a revelation, but a warning, a sign that the mathematics has reached its breaking point. Like a compass that spins in circles at the pole, the laws of physics lose orientation at the supposed beginning. The map cannot contain the territory, and so the greatest triumphs of science are shadowed by humility. The James Webb Space Telescope sees galaxies as they existed 13 billion years ago, but even as it peers deeper, it cannot touch the moment before light. Particle colliders recreate energies unseen since fractions of a second after the Big Bang, but they cannot describe what sparked existence itself. Neutrino detectors listen for particles older than stars, and yet they only hint at a silence that cannot be broken. Science walks upon the thinnest ice, dazzling, precise, astonishing in its reach, yet fragile before the immensity of the unknown. Perhaps this is the true gift of science, not certainty, but perspective. It reveals a cosmos where human comprehension is provisional, where every new understanding deepens the mystery rather than dispels it, where humility is not weakness, but strength. In this light, physics dissolves into philosophy. The lines blur, equations become koans. Every law is both description and question, both map and mirror. The cosmos is not simply out there, waiting to be decoded. It is also within the questions themselves, within the act of asking, within the fragile awareness that to know anything at all is already astonishing. And so, as the story of the universe unfolds, its final truth may be that there is no final truth, only an endless unfolding, a continual deepening, a recognition that the edge of knowledge is itself the most sacred place, a shoreline where the waves of understanding meet the ocean of mystery. The fragility of knowing is also its beauty, That in the face of infinite darkness, humanity dares to ask. That in a cosmos older than time, fleeting beings of dust and breath still raise their eyes and wonder. And that wonder itself, fragile though it is, may be the most enduring light of all. In the deepest sense, the beginning of the universe has never ended. It reverberates still, not only in the faint afterglow of the cosmic microwave background, but in every cell, in every breath, in the quiet pulse of human life itself. All matter that exists today was born in that first fire. Hydrogen, the simplest of atoms, emerged in the first minutes, forged in the cooling furnace of the Big Bang's primordial plasma. Helium followed, stitched together in those earliest instants. Every heavier element, carbon, oxygen, iron, came later, in the hearts of stars, in the violence of supernovae, in the collisions of neutron stars. Yet even those stars drew their raw material from the same beginning. The same first light, stretched and scattered, gave rise to everything that would ever come to be. The human body carries this ancestry within. Its bones hold calcium that was once the ash of a long-dead star. Its blood carries iron that was fused in the last breaths of a supernova. The oxygen in each inhalation was born in stellar cores, then scattered across space before finding a way into Earth's atmosphere. To speak of the beginning is to speak not of something far away, but of something intimate. The Big Bang is not confined to a distant horizon. It is inscribed into the very atoms of the body. In this light, humanity is not separate from the cosmos, but a continuation of it. Every neuron that thinks, every heart that beats, is a ripple of that same primordial expansion. The beginning is not behind us, it is within us, carried forward through matter, memory, and awareness. And so arises a profound reflection. When humans ask about the origins of the universe, it is the universe asking about itself. The atoms that once blazed in the fire of the first stars now arrange themselves into brains capable of wondering. The particles that once danced as quarks and leptons in the infant cosmos now assemble into mouths that speak, hands that build telescopes, and minds that compose equations. The question, what is the beginning, is itself the echo of the beginning, reverberating through conscious thought. There is poetry in this recursion. A universe that was once only energy now contemplates its own birth. A cosmos that began without eyes now gazes back upon itself billions of years later through lenses of glass and mirrors of gold. Awareness is not apart from the cosmos. It is one of its outcomes, one of its instruments of reflection. The story is circular. The beginning folds back upon itself through the act of questioning. But does understanding this origin change the meaning of existence? Does tracing matter back to the Big Bang transform what it means to be human? Or does it simply deepen the wonder? Science can answer with precision the age of the universe, the distribution of elements, the curvature of space-time. It can reconstruct the sequence by which matter cooled, condensed, and formed galaxies. It can measure the faint radiation left from 13.8 billion years ago. But meaning is another terrain. Knowing that every atom of the body is ancient does not explain what it feels like to live. The hydrogen that burns in stars burns also in human blood. But its significance lies not in chemistry alone, but in the awareness of connection. Here, physics and philosophy converge. For some, the knowledge that humanity is dust of stars imparts humility, a reminder of smallness against the backdrop of infinite space. For others, it imparts majesty, a recognition that in this small corner of the cosmos, the universe has become aware of itself. Both reflections are true, and both flow from the same source. The recognition that the beginning is not abstract, but personal. In this fragile awareness, existence finds resonance. The question of origins is not merely about cosmology, it is about identity. The elements of the human body whisper of a history that predates life, predates planets, predates stars themselves. To walk upon Earth is to walk upon matter billions of years in the making. To think is to set in motion atoms older than galaxies. The beginning is not far away. It is as near as the breath in the lungs, as near as the warmth of blood, as near as the thoughts that rise unbidden in the mind. Each one carries the signature of that first fire. Each one is the continuation of a story that began in silence and flame. This understanding does not diminish mystery, it deepens it. If the universe has produced beings who can question, then the act of questioning itself is as much a part of cosmology as any equation. If the cosmos can give rise to reflection, then reflection is woven into the fabric of the universe. Some physicists speculate that consciousness itself may one day be seen as a natural consequence of cosmic evolution, just as inevitable as the birth of stars or the formation of galaxies. Others remain cautious, separating the measurable from the metaphysical. Yet the fact remains, a universe that began as near featureless plasma has, through the slow unfolding of its laws, come to harbor minds that ask why. This is no small transformation. It is the most delicate of emergences. Perhaps then, the meaning of the beginning is not only about time or space, not only about singularities or symmetries. Perhaps its meaning lies also in this, that it has made itself known, that it has become aware, that across billions of years, the cosmos has not only expanded, but awakened. The fragility of this awareness cannot be ignored. Human existence is brief, precarious, vulnerable to extinction. Civilizations rise and fall, stars burn out, galaxies drift apart. Yet even if fleeting, the resonance of knowing is real. For however long it lasts, the universe reflects upon itself through human thought, through human wonder. In this light, to ask about origins is not to seek an answer that will end the questioning. It is to participate in the universe's ongoing act of self-discovery. The cosmos asks about its own birth through human voices, listens through human ears, dreams through human minds. And so the story returns to where it began. Not at the edge of time, but here, in the present moment. In the awareness that the beginning is both far away and intimately near. That every particle carries memory, and every thought carries possibility. That existence itself is the continuation of the first fire, carried forward into reflection, into curiosity, into wonder. The human place in the beginning is not a place of mastery. It is a place of resonance. To live is to echo the birth of the cosmos. To ask is to extend its unfolding. And perhaps, in this fragile awareness, lies the deepest truth of all. That the universe, vast and ancient though it is, has not finished its beginning. It continues, through every star that forms, through every mind that wonders, through every fleeting breath that carries the fire of origins into the silence of now. The search for the beginning is a journey that advances with instruments, equations, and imagination. Yet at its furthest edge lies a silence that resists all attempts to be broken. Every discovery, no matter how profound, draws nearer to a boundary that cannot yet be crossed. The cosmic microwave background, once a final veil, was peeled back by satellites like COBE, WMAP, and Planck, revealing the faint fingerprints of the infant cosmos. Inflationary theory stretched imagination further, proposing an expansion so violent and so brief that it smoothed the universe into the horizon we see today. Quantum fluctuations, once ephemeral, were elevated to the seeds of galaxies and life. Singularities, once dismissed as mathematical curiosities, became the gateways to understanding that time itself may have had a beginning. Yet beyond all these triumphs, one question remains suspended in the shadows. Is the beginning forever unknowable? The problem is not only one of evidence, it is one of perspective. Humanity sees only from within, looking outward across the fabric of space and time. The observable universe stretches some 93 billion light-years across, but it is framed by a horizon, the limit of what light has had time to reach us since the birth of time itself. Beyond that horizon, reality continues, but it remains invisible, unreachable, and perhaps always will. Every measurement of the cosmos is shaped by this boundary. The light of the most ancient galaxies, magnified by the James Webb Space Telescope, carries stories from near the dawn of time, but never from before it. The faint hiss of the cosmic microwave background is a relic from 380,000 years after the Big Bang, but no further back. Even gravitational waves, rippling across the cosmos from colliding black holes and neutron stars, cannot yet pierce the silence of the first instant. In this sense, humanity may be trapped within its own horizon. The beginning may be woven into a veil that no experiment can ever lift, no calculation can ever dissolve. If the laws of physics themselves arose with the universe, then to ask what came before may be to ask a meaningless question. A question without a framework in which to be answered. Stephen Hawking once described this boundary with simple clarity. Asking what came before the Big Bang is like asking what lies north of the North Pole. It is not a failure of imagination, but a limit of meaning. The beginning may not be a point in time, but the origin of time itself. Yet this recognition does not close the story. It opens it further. For if the beginning lies forever beyond the horizon of measurement, then each discovery is not an ending, but an invitation to rethink, to reimagine, to ask again. Cosmology has always lived at this threshold. Theories of cyclic universes propose eternal rebirths, in which beginnings are never singular but infinite, repeating endlessly. The mathematics of quantum tunneling imagines a cosmos leaping into existence from the vacuum with no cause at all. String theory suggests universes born from the collision of higher dimensional brains, with each beginning merely one among countless others. Eternal inflation envisions a vast multiverse, with bubble upon bubble of universes endlessly expanding beyond our reach. Each of these visions stretches human thought to its breaking point. Each offers possibilities, but none yet provide certainty. The horizon remains, a silence that no telescope, no particle collider, no theory has yet breached. This silence is not failure. It is part of the story. The greatest truths of existence may not lie in final answers, but in the awareness of limits. To live within a universe that began is to live within a mystery that may never be fully known. Yet within this unknowing lies awe. Consider the paradox. Humanity, composed of atoms born in ancient stars, now asks questions about the fire that predates stars themselves. Beings who live but a handful of decades stretch thought across billions of years. Fragile creatures on a small planet map the curvature of space-time, weigh the density of dark matter, measure the acceleration of cosmic expansion. Even if the beginning lies forever beyond reach, the act of reaching matters. For every answer opens new abysses. Every glimpse of order reveals new depths of mystery. The horizon of unanswered questions is not static. It recedes as science advances, yet it always remains. An ever-retreating edge, like the horizon at sea. No matter how far one travels, it is always ahead, always waiting, always inviting. And so the search for the beginning becomes more than science. It becomes a reflection on the nature of existence itself. Is the universe a singular event, a one-time unfolding destined to expand into silence? Or is it one of many, part of an eternal cycle beyond human comprehension? Did it emerge from nothing or from a state so alien that human language has no words for it? Perhaps the truest response is not certainty, but humility. To recognize that the universe is both knowable and unknowable, that it reveals itself through light, matter, and mathematics, yet conceals itself behind horizons, singularities, and paradoxes, that the beginning is both the most intimate truth and the most distant. In this humility lies a new kind of awe, for the mystery of the beginning is not only a puzzle to be solved, it is also a silence to be experienced, a silence that stretches across the night sky, a silence carried in the faint hum of background radiation, a silence that whispers in the heart of every question. The universe still unfolds. Galaxies still drift, still collide, still give birth to stars. Planets still orbit suns. Life still arises in fragile corners. And in at least one of those corners, awareness still looks upward, still asks why. The first breath of the cosmos is not over. It continues, carried in expansion, in radiation, in matter, in thought. Every star that shines is part of that breath. Every life that wonders is part of it too. And so the story ends not with an answer, but with silence. A silence that holds awe, mystery, and possibility. The beginning remains the greatest unsolved riddle. It is the horizon that will always remain ahead, always beckoning, always just beyond. Perhaps this is its final gift. Not closure, but wonder. Not certainty, but the invitation to continue asking. To see in the darkness of the cosmos, not emptiness, but depth. To find in the silence not absence, but possibility. The horizon of unanswered questions stretches on, infinite, eternal. And in its presence the human heart is stilled. The universe continues to unfold, and its first breath echoes still. In the end, the journey through beginnings circles back not to an answer, but to a silence. From ancient myths of cosmic eggs and divine sparks, to the equations of Einstein and the vision of Hubble, the story has always been the same. Humanity, fragile and brief, turning its gaze to the stars to ask where it came from. Each chapter in that story, has unfolded like layers of light peeling back the darkness. Lemaitre's primeval atom, Penzias and Wilson's accidental whisper of cosmic fire, the satellites that mapped the faint ripples of creation, the theories that stretched imagination into realms of inflation, quantum origins, and multiverse skies. Science traced the outlines of the beginning, yet at its very edge, the image blurred. Singularities fractured equations, horizons enclosed vision. The laws themselves dissolved into the same mystery they sought to explain. Each step forward revealed new abysses. Each breakthrough, however luminous, cast shadows of deeper questions. And still, within those shadows, awe remained. For the beginning is not only behind, hidden in time's first instant. It is within. Every atom in every body carries echoes of the first fire. The iron in blood was forged in stars that themselves were kindled by the cosmos's earliest sparks. The carbon in life, the calcium in bones, the oxygen in breath, all trace their lineage back to that single act of becoming. The universe is not only observed, it is lived. Perhaps this is the quiet revelation of the search. The universe, through human thought, reflects upon itself. Every question asked is the cosmos listening to its own origins. Every wonder is its echo. And so the story closes not with resolution, but with resonance. The beginning may remain forever hidden beyond horizons of light and time, but its presence is undeniable. It breathes in galaxies drifting apart, in black holes bending space-time, in stars igniting in darkness, and in human hearts that still ask why. The first breath of the universe has never ceased. It continues still, carried in expansion, in radiation, in matter, and in thought. And so the silence is not an ending. It is an invitation to wonder, to imagine, to listen. The universe is still unfolding, and its first breath echoes still.